Today we are going to begin with the chapter Matrices. So what is a matrix? Matrix is basically a rectangular arrangement of numbers arranged in rows and columns. An example of a matrix would be, it's written in square bracket, say 1, 5, minus 9, 2, 3, 6, where there are 2 rows and 3 columns. We'll come to the order in detail after some time, but the number of rows are written first, into we write the number of columns. There are 3 columns, so 2 cross 3 becomes the order of this matrix. Another example is, say, 1 by 2, 7, 8, minus 7 by 3. So here we have 2 rows. So first we write the number of rows into, then we write the number of columns, that is also 2. So here the number of rows and the number of columns are equal and the order is 2 cross 2. So first we had matrix. Now next we'll understand what the order of a matrix is. Order of a matrix is equals to number of rows into number of columns. Example, let's say 1, 2, 3, minus 9, 12, 13, 7, minus 8. Another example, here the order is 2 rows and 4 columns, 1, 2, 3, 4 columns, and let's say 1, 7, minus 2, 3, minus 9, 8, minus 5, minus 7. So this is 1, 2, 3, 4 rows into 2 columns. As we can clearly see, 2 cross 4. So in case of order of a matrix, two cross 4 is not equals to 4 cross 2 for an order of a matrix. Okay, next is the element of a matrix. Each number or entity in a matrix is called its element. Okay, in this particularly you might be asked for a 1 marker question that say find the number of elements in a matrix with order 2 cross 4. So solution, the number of elements will be equals to, see, this is a 2 cross 4 matrix. So if there are 2 rows and 4 columns, the total number of elements become 8, which is 2 into 4. So the number of elements will be equals to 2 into 4, that will be equals to 8. Okay, please understand that this is the order, whereas this multiplication is the number of elements that is contains. Okay, now we come to the different types of matrices. Okay, let's begin by considering a matrix capital A. We always denote a matrix by a capital alphabet with order, say m cross n. So the first type of matrix is a row matrix. A matrix is a row matrix if there is only one row. So the number of rows is equals to 1. So there should be only one row. For example, say 1, 2, 3, 4. So the total number of rows is 1 and the number of columns is 4. So 1 cross 4 is a row matrix. Another example, say 5 minus 9. So this is 1 cross 2. This is also a row matrix where there is only one row. Second is a column matrix. Column matrix is a matrix that has only one column. So n will be equals to 1 in this case. For example, we have say 1 minus 5, 8. So this has 3 rows and 1 column. So the number of column is 1, hence it is a column matrix. Column matrix is called so because this looks like just one column, that is why it's called a column matrix. Another example, say minus 9, 2, 3, 4. So number of rows 1, 2, 3, 4. First we add the number of rows in the order of a matrix into the number of columns, that is just 1. So if a matrix has just one column, it is called a column matrix. Number 3, a square matrix. A matrix is a square matrix when the number of rows and the number of columns are equal, that is n will be equals to n. For example, say 1, 2, 3, 4. This is a square matrix where the order is 2 cross 2. Number of rows and the number of columns are equal. Another example, say minus 3, 2, 5, 6, 9, 2, 5, 3, minus 2, 3 rows and 3 columns. So 3 cross 3 is the order. Number of rows, number of column equal. This is a square matrix. Number 4, the fourth type of matrix is a rectangular matrix. Where the number of rows and the number of columns are unequal, that is m is not equals to n. So an example for this would be 1, 2, 3, 4, 5, 6, 7, 8. So there are 2 rows and 4 columns. So this is a rectangular matrix. Or say 5, 9, minus 3, minus 8, minus 2, 6. So number of rows 3 into number of columns 2. Number of rows and the number of columns do not match. This is also a rectangular matrix. Fifth type of matrix is the zero or null matrix. So in this type of matrix, all the elements is basically 0. For example, say 0, 0 or say 0, 0, 0, 0 or say 0, 0, 0, 0, 0, 0. The order can be anything, but all the elements of this should be 0. This is a 0 or a null matrix. Number 6 is a diagonal matrix. So a diagonal matrix, first of all, is only defined for a square matrix. So it should be a square matrix. And second point is that all the elements are 0 except for the elements in the principal diagonal. So what is the principal diagonal? Here, consider this square matrix. So this is one diagonal, this is another diagonal. This one is called the principal diagonal. This diagonal is called the principal diagonal. So example of a diagonal matrix is, say, 1, 2, 3. All the other elements will become 0. So this is a square matrix and the principal diagonal elements are non-zero. Others all are 0. Another example would be, say, 5 minus 3, 0, 0. This is also a diagonal matrix where the principal diagonal elements are non-zero and all the other elements are 0. Then number 7 is a unit matrix or an identity matrix. So first thing, it should be a square matrix. Second, all the elements are 0 except for the diagonal elements whose all the elements have value 1. So example would be, say, this is a diagonal matrix. So the principal diagonal, all the elements of the principal diagonal has value 1 and all others have value 0. So this is a square matrix as well. So 1, 1, 1, 0, 0, 0, 0, 0, 0. This is an identity matrix or a unit matrix. Okay. Next we are going to learn transpose of a matrix. So let A be a matrix, then its transpose is denoted by A, and we write a small t at the superscript of this one, denoting that this is A transpose. Transpose is obtained by interchanging its rows and columns. An example, let's say a matrix A is equals to 1, 2, 3, 4, 5, 6. So A transpose will become what we'll do is we'll write the this first column in terms of row, or we'll write the first row in terms of column. So this becomes 1 4. Second row becomes second column, and the third row becomes third column. This is what a transpose is. Another example, say a matrix B is equals to -2, -3, 5 and 9. So B transpose will be equals to, the first row will become the first column and the second row will become the second column. So this is a transpose of B. Okay. And the next topic is the equality of matrices. So a matrix is said to be equal if it satisfies these two criteria. First, both the matrices should have same order, and second, their corresponding elements should be equal. So let's deal with a question relating this. Say find the value of x, y, a and b if x minus 2, y, a by 2, b plus 1 is equals to 0, 3, 1, 5. So solution. So they are given to us as equal. So their corresponding elements should be equal. So if their corresponding elements is equal, so this will be equals to this. So x minus 2 will be equals to 0. From this we get x equals to 2. Second, y will be equals to 3. Third, a by 2 is equals to 1, which implies a is equals to 2. And fourth, b plus 1 will be equals to 5, which implies b is equals to 4. So this is how we solve questions for equality of matrices. Next topic is our addition or subtraction of matrices. So there is one rule that you need to remember for addition or subtraction of matrices is that their order must be same. Two matrices can be added or subtracted if they are of the same order. So let's understand this by solving the question itself. Say let we consider a matrix A equals to 5, 4, 3, minus 2. Matrix B equals to -3, 0, 1, 4. And C is equals to 1, -3, 0, 2. Find number 1, A plus B and B plus A. Number 2, A plus B plus C and A plus B plus C. Number 3 is A plus B is equals to B plus A question mark. and number 4 is A plus B plus C is equals to A plus B plus C, question mark. In each case, write the conclusion if any that you can draw. Solution. Okay, so first we need to find for the first part A plus B. So A plus B will be equals to this matrix A is 5, 4, 3 minus 2. Plus the matrix B is minus 3, 0, 1, 4. While adding two matrices, what we do is we add the corresponding elements. Like here, we'll add 5 and minus 3. So this will be equals to 5 plus minus 3 in the first row, first column. This will become 4 plus 0, first row, second column. This will become 3 plus 1 and minus 2 plus 4. The second row, second column, second row, second column. So what we get inside the matrix is 5 minus 3, 2, 4, 4 and 2. And B plus A will be equals to minus 3, 0, 1, 4, 5 plus 5, 4, 3 minus 2. So this is equals to minus 3 plus 5. We'll add the first row, first column, first row, first column. 0 plus 4, first row, second column, first row, second column. 1 and 3, second row, first column, second row, first column, and 4 plus minus 2, second row, second column, and second row, second column. So the final result that we get is minus 3 plus 5 is 2, 4, 3 plus 1, 4, and 4 minus 2 is 2. So this is our first part. Second part, we need to find A plus B plus C. So A plus B is 5, 4, 3 minus 2 plus 3 minus 3, 0, 1, 4 plus C is 1 minus 3, 0, 2. So this will be equals to, so this plus this, 5 minus 3, 4 plus 0, 3 plus 1, minus 2 plus 4. Solving this 2, and we have 1 minus 3, 0, 2. So we get 5 minus 3, 2, 4, 4, 2 plus 1 minus 3, 0, 2. So from here we get 2 plus 1, 4 minus 3, 4 plus 0 and 2 plus 2. So 3, 4 minus 3 is 1, 4 and 4. Now we'll add A plus B plus C. So from here we have 5, 4, 3 minus 2 plus minus 3, 0, 1, 4 plus 1 minus 3, 0, 2. So this is 5, 4, 3 minus 2 remains as it is, plus on adding these two we'll get minus 3 plus 1, 0 minus 3, 1 plus 0 and 4 plus 2. So we have 5, 4, 3 minus 2 plus minus 2 minus 3, 1, 6. This is equals to 5 minus 2, 4 minus 3, 3 plus 1 and minus 2 plus 6. So finally we get 5 minus 2 is 3, 1, 4 and 4. So in the third part it was asked that is a plus b equals to b plus a, and what conclusion can we draw? So here we can see that a plus b and b plus a is equal. In the third part we have yes, a plus b is equals to b plus a. So the conclusion is that matrix addition is commutative. And the fourth part we have a plus b plus c and a plus b plus c. So they are also equal. So yes, a plus b plus c is equals to a plus b plus c. So the conclusion from here we draw is that matrix addition is associative. If you remember, these are basic properties that are taught in smaller classes. If a plus b equals to b plus a, then we say that addition is commutative. Since these are matrices, that's why we are saying that matrix addition is commutative. And if we add first a plus b, and to the sum if we add c, or to a if we add the sum of b and c, the result is same, and we say that addition is associative. Since we are dealing with matrices here, we are saying matrix addition is associative. Okay, so we saw how we add this matrices. Now we will see a question relating how we subtract these matrices. So if A is equals to 5, 4, 3 minus 1, B is equals to 2, 1, 0, 4, and C is equals to minus 3, 2, 1, 0, find number 1 A plus C, number 2 B minus A, and number 3 A plus B minus C. So in the solution, let's do the first part. A plus C will be equals to 5, 4, 3 minus 1 plus 2, 1, 0, 4, which is equals to 5 plus 2, 4 plus 1, 3 plus 0, and minus 1 plus 4. So this is 6, 5, 3, 3. Second part, B minus A. This is equals to 2, 1, 0, 4 minus 5, 4, 3 minus 1. So this will be equals to 2. If there is minus in between, so we'll subtract them. So 2 minus 5, then 1 minus 4, 0 minus 3. This is how we subtract matrices. We'll subtract the corresponding elements like we added the corresponding elements. So this will become 4 minus minus 1. So this is minus 3, minus 3, minus 3, and 4 plus 1. So which becomes minus 3, minus 3, minus 3, and 4 plus 1 is 5. And the third part, A plus B minus C. So A we have 5, 4, 3 minus 1, plus B we have 2, 1, 0, 4, minus C we have minus 3, 2, 1, 0. So this is equals to 5 plus 2, 4 plus 1. First we are dealing with this 2, 3 plus 0, and minus 1 plus 4, minus 3, 2, 1, 0. So this is 6, 5, 3, and minus 1 plus 4 is 3, minus 3, 2, 1, 0. So we have 6 minus minus 3, 5 minus 2, 3 minus 1 and 3 minus 0. So this becomes 6 plus 3, 5 minus 2 is 3, 3 minus 1 2, 3 minus 0 3. So the result becomes 9, 3, 2, 3. So this is how we solve addition and subtraction of matrices. The next topic in matrices is the additive identity and additive inverse. So the additive identity of matrix A with order M cross N is the null matrix with the same order. For example, we have say 2, 3, 5, 1, 2, 7. So the additive identity will become 0, 0, 0, 0, 0, 0. So the null matrix of the same order. Why we are taking the same order is because we can only add two matrices if they are of the same order. So this is our additive identity in this case, and on adding these two we'll get back the same matrix, that is 2, 3, 5, 1, 2, 7. So that is why this is called the additive identity, a null matrix with the same order as the matrix that is given to us. And additive inverse of matrix A with order M cross N is basically minus A. So for example, if A is 1, 2, 3, 4, the additive inverse of A is minus A, that is equals to minus of 4. What happens is this minus gets multiplied by each and every term. So we get minus 1, minus 2, minus 3, minus 4. This is the additive inverse of minus A. Another example, this is the first example. Second example, the additive inverse of say 1, 2, minus 7, 3, minus 6, 2 is minus of 1, 2, minus 7, 3, minus 6, 2, which is equals to minus minus plus 7, minus 3, 6, minus minus becomes plus and minus 2. This is how we find the additive inverse. And what is the purpose of additive inverse is that, so A plus the additive inverse will be equals to 0. This is the null matrix of the same order as A. So what we get is 1, 2, minus 7, 3, minus 6, 2. So if we add the additive inverse, that is minus 1, minus 2, 7, minus 3, 6, minus 2. What we get is 1 minus 1, 2 minus 2, minus 7 plus 7, 3 minus 3, minus 6 plus 6 and 2 minus 2. So all the elements are 0. So we are getting a null matrix of the same order. So on adding the matrix and its additive inverse, we get a null matrix of the same order as that of A. And now we'll see how we solve an equation for a matrix. So note, if a plus x is b, we can take a on the other side. So plus a goes to the other side, it becomes minus a. And if suppose they would have been minus a goes to the other side, it would become plus a. So we can do this for addition or subtraction. So question: if a is equals to 8, 6, minus 2, 4 and b is equals to minus 3, 5, 1, 0, then solve for 2 cross 2 matrix X such that number 1, a plus x is equals to b, and number 2, x minus b is equals to a. So solution, let's solve the first part first. So a plus x is given to us as b. So from here we have x is equals to b minus a. The matrix B is minus 3, 5, 1, 0 minus the matrix A is 8, 6, minus 2, 4. So what we get is minus 3, minus 8, 5, minus 6, 1 minus of minus 2 and 0 minus 4. So this is minus 11, 5 minus 6 is minus 1, minus into minus is plus, 1 plus 2 is 3, and this is minus 4. And for the second part, we have x minus b is equals to a. So from here we get x equals to a plus b, which implies x is equals to a will replace as 8, 6, minus 2, 4 plus b will replace as minus 3, 5, 1, 0. So we get 8 minus 3, 6 plus 5, minus 2 plus 1 and 4 plus 0. So we have 5, 11, minus 1 and 4 as our elements. With this we come to the end of this lecture. In the next lecture we will be dealing with multiplication of matrices by a scalar and also the multiplication of matrix by another matrix. Thank you.